is Engine Kenneth Maldes, a marine engineering student at TMMA College of Southern Philippines. In this video, I'll be explaining the four laws of thermodynamics. And as a marine engineering student, I'll be providing real-life examples on board ships. So, these laws might sound scientific, but they actually explain how energy, heat, and systems works around us, especially in marine environments. So let's start with the first one, which is actually called zeroth law. Zeroth law of thermodynamics: if two systems are each in thermal equilibrium with a third one, then they are equilibrium with each other. For example,
on board a ship, we utilize the zeroth law of thermodynamics. Imagine the engine coolant, engine block, and a temperature sensor all showing the same temperature. When these components reach the same temperature, it indicates they are in thermal balance, ensuring optimal performance. This balance is crucial as it prevents overheating. If any part's temperature diverges, adjustments can be made to restore stability. By maintaining a stable, shared temperature, we can ensure the engine operates efficiently and safely throughout its journey.
Next is the first law, energy conservation. The first law says energy can be created or destroyed, only converted from one to another. For example,
when a ship's engine burns fuel, chemical energy transforms into mechanical energy, enabling the propeller to move. As energy is used, heat energy is created, which must be managed by the ship's cooling system to maintain efficiency. According to the first law of thermodynamics, all energy is conserved. None simply disappears, it changes forms. Electricity generated also adheres to this principle, converting potential energy from sources into electrical energy for use.
The second law, entropy and heat flow. This law says heat flows naturally from hot to cold, and the disorder is called entropy. And the systems always increase unless energy is added. For example,
think of a car engine. When it runs, it generates heat, transferring that heat to the cooling system, which is then released to the surrounding environment. This process never happens in reverse. Cold water doesn't heat the engine. That's a key principle of the second law of thermodynamics. Over time, the engine faces wear and tear. Factors like corrosion or fuel breakdown are all signs of increasing entropy in the system. Lubricant degradation is another example. Oils break down and lose their effectiveness, contributing to entropy as parts become less efficient. To combat these effects, regular maintenance is essential. It's how the crew fights against rising entropy and keeps the system running smoothly.
In third law, absolute zero is unreachable. This law tells us you can never cool anything down to absolute zero. For example,
in LNG carriers, gas is cooled to -160 degrees. Even at these extreme temperatures, we are still far from absolute zero, which is -273.15 degrees Celsius. No matter how much we cool a system, there's always a bit of motion. This means true absolute zero remains impossible.
and that's all. Thank you for watching. I hope you learned something.